Welcome to International Wire Group, your trusted source for copper and copper alloy wire solutions. Today, we're taking you behind the scenes to explore the foundational process of wire drawing. Wire drawing is a precise two-step operation that reduces the diameter of a copper rod to a finer gauge while preserving its surface finish and mechanical properties. As the first stage in conductor and cable manufacturing, the process involves pulling the copper rod through a series of progressively smaller diamond dies to reach the desired wire size. Before drawing begins, the rod undergoes surface cleaning at the supplier's facility to remove oxides, impurities, or scales that could damage the dies during drawing. An oil-based or synthetic lubricant is applied to remove heat and reduce friction and prevent die wear during the drawing process. The choice of lubricant depends on the intended application and drawing machinery requirements. The process starts with standard 8mm copper rod in coil form. Made from C11000 electrolytic tough pitch copper, ETP copper, or C10100 oxygen-free electronic copper, OFE copper, depending on the application. Copper wire rod is electrolytically refined and soft-tempered. It delivers excellent conductivity and workability. The first stage of wire drawing, called the intermediate draw, is performed by the rod breakdown machine. In this stage, an 8mm rod passes through multiple dies, gradually reducing its diameter to typically 12 AWG, 2.053 millimeters. As the diameter decreases, the rod's length increases to maintain consistent volume. After passing through dies, the wire reaches a hard-tempered state and won't be annealed again until it's drawn to its final gauge. Most dies reduce the wire by 1 AWG size, but machines with overdraft capability use fewer dies, cutting tooling costs. Throughout the process, continuous lubrication minimizes friction and heat, protects the dies, and preserves the wire's surface quality. Oil-based lubricants are economical and commonly used for larger diameters, while synthetic lubricants are ideal for finer wire and cleaner operations, but may be more expensive to maintain. The 12-gauge wire is then routed through a down coiler equipped with a traversing unit that ensures uniform layering onto the stem. This organized coiling prevents tangles and enables smooth unwinding during the next drawing phase. The coiled wire is collected into a 4,000-pound capacity stem, ready for the next operation. The filled stem is transported by forklift to the SAMP machine, where the wire undergoes its final draw. A high-mounted pulley system guides the wire into alignment for its final pass, where precise dimensions and surface quality are achieved. The SAMP machine is where the wire achieves its final diameter and a precise surface finish. It houses a series of integrated components that work in perfect coordination. Draw section, which terminates at the finish die and finish capstan. The inline annealing section. The cooling section. The tension control spooling section. Digital controller, accessed through the digital control panel interface, ensures that these four components work in unison. Inside the draw section of SAMP machine, wire is pulled through a series of precision dies and capstans, which work in tandem. This precise alternate arrangement ensures uniform elongation while protecting the surface from stress or scoring. Each die reduces the diameter of the wire, while each capstan pulls it forward and maintains controlled tension. The wire enters at 12 gauge, or roughly 2 millimeters, and is gradually drawn thinner as it passes through each die capstan pair. Before exiting the draw box, the wire proceeds directly into the finish die, where wire reaches its final diameter. 22 gauge or 0.0644 millimeters. The finished capstan pulls wire through the finish die and directs it into the annealer section. To maintain production efficiency, drawing machines operate at speeds reaching hundreds of meters per minute. The digital control panel continuously monitors and adjusts line speed in real time, ensuring smooth movement, stable tension, and perfect synchronization across all SAMP components. Proper tension ensures uniform wire diameter reduction without breaking. As RPM levels rise or fall, the wire's motion through the drawing and annealing sections shifts accordingly. We move on to the inline annealing section, the key component responsible for heating the wire to the necessary temperature for annealing. This section begins at the initial annealer contact pulley, where current is first introduced into the wire. Then wire passes over a series of conductive pulleys, which maintains a steady connection while spinning. The current flow initiates the resistive heating process, preparing the wire for annealing. In the inline annealing section, the wire itself becomes the heating element, generating heat as current passes through it, and this localized heat softens the wire, relieving internal stresses accrued during the draw process. The annealing process restores ductility and soft temper, transforming the conductor into one that is flexible and ready for further applications. Annealing occurs at specific temperatures, typically between 350 and 650 degrees Celsius, depending on the desired level of softness. Continuous inline annealing is a manufacturing advantage. It eliminates the need to batch anneal reels of hard wire, allowing to significantly lower the production time and cost. As annealing is completed, the wire proceeds towards the cooling section. Immediately after annealing, the hot wire is submerged in a cooling section filled with circulating fluid. This rapid thermal shock halts the annealing effect and locks in the mechanical properties. The wire is now stabilized and ready to be spooled. Next, the wire passes through the tension control unit. As the wire softens during annealing, it becomes more vulnerable to deformation, so maintaining consistent tension is essential. The unit adjusts automatically for speed variations, ensuring smooth and controlled movement between the draw machine and the spooler. This guarantees that the wire is wound evenly, without loops or inconsistencies, while preserving strength and integrity. From here, the wire moves toward its final destination, the spool. It travels upward, guided into the spooling station. Here, the finished 22-gauge wire is spooled on 22-inch plastic reels. Thanks to Tension Control Unit, the wire wraps neatly, with even layers, without stress or slack. Each reel, identical in form and quality, holds wire that is ready for storage or transport. Before these reels leave the facility, they pass through stringent quality inspections handled by trained inspectors. Each wire is tested for diameter and ovality. Surface finish, tensile strength, electrical resistance, and elongation to ensure it meets every specification. All evaluations follow ASTM and customer-specific standards, ensuring total compliance. Every box is checked, every measurement logged, so every reel leaves certified and trusted. This isn't just quality control, it's a guarantee of performance and precision. Thoroughly inspected and certified, the wire moves forward for final use. Each spool carries a product engineered for performance. This is 22-gauge copper wire, known for its flexibility, soft temper, and high conductivity. It is engineered for demanding electrical and electronic environments, from appliances and automotive systems to telecommunications and beyond. This wire is ready to connect the world. For more information, contact us today.